All right, so now we're talking about slope. And so when we talk about that, we're going to think about if you've ever gone skiing or maybe you've ever gone hiking up a mountain. And you know how, like, when you go skiing, you have different levels of the harder the courses. Like, you want to stay on the blues, or you want to, challenge yourself and go up to the blacks. Well, that means that that's got a greater slope on that mountain, so you're going to go down it faster the higher the number. Or if you're going to go hiking, you want to make sure that you can go up a mountain that you can travel up. It's going to take a lot more effort to go up something that's steeper than it is to go on something that has a little bit less of a slope. So if we talk about something, or if you're going to go skiing or anything like that, and let's just say it's got a 20% grade or slope of that mountain, well, that means that for every 20 feet that mountain, it goes up 20 feet for every 100 feet horizontally. And so, just on average, it's going to go up 20 for every 100 it goes across. And that's sort of what slope is. So really, your mountain is not like a stair step like that. Your mountain's more like this as it's going up. And so that's where we get that grade or that steepness. If you've ever traveled in the mountains, if you're driving in a car, you're having to drive up it or drive down it, then it's just making you go a lot faster. If you're going down it, the higher that grade is. So that's sort of what slope is in the real world. So mathematically, we talk about the rise. Slope is often referred to rise over run. And rise is that vertical change that it makes, how much it's rising up. So in this instance, it was rising up 20, and then the run is that horizontal change. So how much it's running over this way. And those are, approximates. Obviously, if you're, we can't go measured down like that a mountain, but if just on average, it's going to be about, something like 20 over 100 if it's a 20% grade. So, so we often think of slope as that rise over run. So we're going to say, how much does something rise up? The slope ratio is that rise over run. Now, m is the variable that's often used for slope. So just in general, we're going to say m then is equal to rise over run. Okay, well, let's look at a couple of graphs and see if we can just see on a graph if we can determine what the slope of a linear function is. So remember, a linear function is a straight line. All right, so let's say we have a point here on our line. And a point here on our line. And we're going to go ahead and draw a line through this so that we actually see what this sort of looks like. If I can draw it straight. Okay, so normally you're going to be given like these 2 points here. And we're going to see, remember, slope is that rise over run. So what's it taking us, how are we getting to that next step? Well, we've got to rise up this many units. We need to get up to here. Well, how many units are we rising up? We're going 1, 2, 3, 4. We'll rise 4 units. And then how many are we running over? So that takes us straight up here, 1, 2, 3, 4 units. And then we're running over to our next point, and that is 3 units is our run. Well, notice on that number line, if you're rising up, that's positive 4 units. And then if you're going to the right, that's positive 3 units. So we have a slope of 4/3. And so that's the slope of this line. All right, so let's look at another one. Let me draw a line through those 2 points. And you can go from one point to the other. It doesn't matter which one you start from. I can start from here and say, okay, well, I'm having to go down to get to this next point. So I've got to go to right here, and that means change colors. I'm going to go down 3 units. Well, if I'm going down on my number line, that makes it a negative. Then we're having to run over 2 units. Well, going to the right is positive. So this is my rise. This is my run. So remember, rise is always that vertical change. Run is always your horizontal change. So that slope went down -3 over 2. So that's the slope of that line. And all we have to do is just count from one unit to the next. And most of the time, those are probably going to be labeled for you, like with the actual points there. Now, notice that this line, the first one that we did with the slope of 4/3, it rose to the right. So it's rising, the entire line is rising to the right. And we talk about what's the end behavior. So what's happening if to the line as I'm going this way, like, so in this case it's rising up. Well, we call that a positive slope because it's increasing. Both values are in the positive number, so it's a positive slope. So you want to recognize that. Notice that when this one is going left to right, it is falling, or it's going down to the right. And so notice it had a negative slope. And so that's very important to also remember. So it's got a negative slope if it's going down. That end behavior is headed downward. Or it has a positive slope if that end behavior is going up. So now there's another way that you can do this. You don't also have to have graphs to show you this. There's a formula for it. So we've talked about that slope, or that M, is that change in the vertical units. It's the rise, how much it's rising, over the change in the horizontal units. Well, what if we're only given the 2 points on that line? Well, we have a formula for that. So remember, the vertical change has to do with your y values. So if we take the difference in the 2 y values that were given, that's going to be how many units that's changing. The same thing with the horizontal. Then horizontal are your x values. So we're going to take the difference in those two x values. So let's just say we are given 2 points on the line. So there's one ordered pair. Here's the other ordered pair. So 1, 2, and 7, 5. Remember, every ordered pair is x value, then a y value. X value and a y value. Now we can say either one of these is the x1 and the y1. So for this example, let's just say this is our point 1 that we're given, and this is the point 2 that we're given. So we'll say this is x1 and y1, and then x2 and y2. Well, notice our formula then says take the difference in those two y values. Well, we labeled 5 as y2. So 5 minus the other y value, which is 2. So we're taking the difference in these two y values. And the key to this formula is if I start with this 5 here and subtract the other point 2, then I have to start with this x value. It's coordinate x value. So on the bottom, then we've got 7 minus the other x value, which is 1. So just remember, if I'm taking the difference in my y's, then I take the difference in my x's. So 5 minus 2 is 3, and 7 minus 1 is 6. And we can always reduce those fractions, so 3 over 6 is also 1/2. So therefore, that would be the slope of those two lines. Now, if I went and drew those on a coordinate grid, I could also count up and over, but you don't always have graph paper with you, so a lot of times finding these slopes, I'm going to go ahead and just, using this formula is, just an easier way to do it. Okay, so let's get 2 more points. So let's just say find the slope between these 2 points. All right, let's throw some negative numbers in there just to confuse us a little. So let's say -5/8 and -7, -3. Okay, so remember, we have x and y, x and y. So we can say this is point 1, this one's point 2, which makes this x1, y1, x2, y2. All right, so remember our formula is the difference in those two values, y2 minus y1 and x2 minus x1. So we have to pay very close attention to some of these negative signs and make sure that we do not drop any of them. So if we said y2 is -3 minus y1, which is 8, over x2, which is -7, minus x1, which is -5. And that's a common mistake, is to just drop one of those negative signs. But remember, if you've got a negative, if you're subtracting a negative number, then that turns it into a positive. So we still have -3 minus 8 over -7 plus 5. Well, -3 minus 8 is -11. And -7 plus 5 is a -2. Okay, well, -11 over -2 is not really an appropriate answer, because we know a negative divided by a negative ends up being a positive. So that slope is 11 over 2, or 11 halves. Now, we really like slope to be left in fraction form. This is where fractions really become our friends, and we love fractions for slope because then if we have to go draw a line, we know exactly how many units to rise up, we know exactly how many units to run over. So just remember, we really like fractions there, and we don't want those in decimal form, but we do want them in the lowest fractions.